Forget everything you know. Hi, and welcome to the Trust Channel, and today I'll be going over ideas and my thoughts on the multiverse. Who are you in this vast multiverse? Is indeed a good question. This also depends on what universe we are. Are we Terra Prime, Earth 1, or are we Earth 1600? I say this because we always assume we are at the centre of things. But would you want to know the implications of the multiverse? They are fascinating and terrifying at the same time. But first, look out at the universe all you want with arbitrary, powerful technology, and you'll never find an edge. Space goes on as far as we can see, and everywhere we look, we see the same things: matter and radiation. In all directions, we find the same telltale signs of an expanding universe. The leftover radiation from a hot, dense state. Galaxies that evolve in size, mass, and number. Elements that change abundances as stars live and die. But what lives beyond our observable universe? Is there an abyss of nothingness beyond the light signals that could possibly reach us since the Big Bang? Who knows? Is there just more universe out like our own out there, past our observational limits? Or is there a multiverse, mysterious in nature and forever unable to be seen? Unless there's something seriously wrong with our understanding of the universe, the multiverse must be the answer. The multiverse is an extremely controversial idea, but at its core, it's a very simple concept. Just as the Earth doesn't occupy a special position in the universe, nor does the Sun, the Milky Way, or any other location. The multiverse goes a step farther and claims that there's nothing special about the entire visible universe. The multiverse is an idea that our universe and all that's contained within it is just one small part of a larger structure. This larger entity encapsulates our observational universe as a small part of a larger void that extends beyond the limits of our observations. That entire structure, the unobservable universe, may itself be a part of a larger space-time that includes many other disconnected universes, which may or may not be similar to the universe we inhabit. If this is the idea of the multiverse, I can understand your doubts at the idea or notion that we could somehow know whether it does or doesn't exist. After all, physics and astronomy are sciences that rely on measurable, experimental, or otherwise observational confirmation. If we are looking for evidence of something that exists outside of our visible universe and leaves no trace within it, it seems that idea of a multiverse is a fundamentally untestable concept. However, there are all sorts of things that we cannot observe that we know must be true. Decades before we directly detected gravitational waves, we knew that they must exist because we observed their effects. Binary pulsars spinning, neutron stars orbiting around one another, were observed to have their revolutionary periods shortened. Something must be carrying energy away, and that thing was consistent with the predictions of gravitational waves. LIGO and Virgo provided confirmation for gravitational waves via direct detection. We already knew that they needed to exist because of this indirect evidence. So if we cannot observe the multiverse directly, what indirect evidence do we have for its existence? How do we know that there is more unobservable universe beyond the part we can observe? And how do we know that what we call our own universe is likely just one of many embedded in the multiverse? We can look out at the edge of this observable universe. We find that the light rays emitted from the earliest times from the cosmic microwave background make particular patterns on the sky. These patterns not only reveal the density and temperature fluctuations that the universe was born with, as well as the matter and energy composition of the universe, but also the geometry of space itself. We can conclude from that space isn't positively curved like a sphere or negatively curved like a saddle, but rather spatially flat, indicating that the unobservable universe likely extends far beyond the part we can access. It never curves back on itself, it never repeats, and it has no empty gaps in it. If it is curved, it has a diameter that's hundreds of times greater than the part we can see. That might indicate that there's more unobservable universe beyond the part of our universe we can access, but it doesn't prove it, and it doesn't provide evidence for a multiverse. There are, however, two concepts in physics that have been established far beyond a reasonable doubt, and that is one is cosmic inflation and quantum physics. Quantum inflation is the theory that gave rise to the hot Big Bang rather than the beginning with a singularity. As a physical limit to how hot and how dense the initial early stages of our expanding universe could have reached. If we achieved arbitrary high temperatures in the past, there would be clear signatures that aren't there. Large amplitude temperature fluctuations early on, seed density fluctuations limited by the scale of the cosmic horizon, and leftover high energy relics from early times, like magnetic monopoles. These signatures are all missing. The temperature fluctuations are at the 0.003% level. The density fluctuations exceed the scale of the cosmic horizon. The limits on monopoles and other relics are incredibly stringent. The fact that these signatures aren't there have an enormous implication to them. The universe never reached those arbitrary high temperatures. Something else came before the hot Big Bang to set it up. That's where cosmic inflation comes in. Theorized in the early 1980s, it was designed to solve a number of puzzles with the Big Bang, but did what you'd hope for any new physical theory. It made measurable, testable predictions for observable signatures that would appear within our universe. We see the predicted lack of spatial curvature. We see an adiabatic nature of the fluctuations the universe was born with. We've detected a spectrum and magnitude of initial fluctuations that jibe with inflation's predictions. Jibe with inflation's predictions. We've seen the superhorizon fluctuations that inflation predicts must arise. We may not know everything about inflation, but we do have a very strong suit of evidence that supports a period in the early universe where it occurred. It set up and gave rise to the Big Bang and predicts a set and spectrum of fluctuations that gave rise to the seeds of structure that grew into the cosmic web we observe today. Only inflation, as far as we know, gives us predictions for our universe that match what we observe. Also, there's quantum mechanics. Inflation is treated as a field like all the quanta we know of in the universe, obeying the rules of quantum field theory. In the quantum universe, there are many counterintuitive rules that are obeyed, but the most relevant one for our purposes is the rule governing quantum uncertainty. While we conventionally view uncertainty as mutually occurring between two variables, momentum and position energy, and time, angular momentum of mutually perpendicular directions, and so forth, there's also an inherent uncertainty in the value of the quantum field. As time marches forward, a field value that was definitive at an early time now has a less certain value. You can only ascribe probabilities to it. In other words, the value of any quantum field spreads out over time. So we have an inflating universe on one hand and quantum physics on the other. We can picture inflation as a ball rolling very slowly on top of a flat hill. So long as the ball remains atop of the hill, inflation continues. When the ball reaches the end of the flat part, however, it rolls down into the valley below, which converts the energy from the inflationary field itself into matter and energy. This conversion signifies the end of cosmic inflation through a process known as reheating, and it gives rise to the hot Big Bang we're all familiar with. But here's the thing. When your universe inflates, the value of the field changes slowly in different inflating regions. The field value spreads out by randomly different amounts and in different directions. In some regions, inflation ends quickly, in others it ends more slowly. This is the key point that tells us why multiverse is inevitable. Where inflation ends right away, we get a hot Big Bang and a large universe, where a small part of it might be similar to our own observable universe. But there are other regions outside of the region where it ends, where inflation continues for longer. Where the quantum spreading occurs in just the right fashion, inflation might end there too, giving rise to a hot Big Bang and even a larger universe, where a small portion might be similar to our observable universe. But the other regions aren't still just inflating, they are also growing. You can calculate the rate at which the inflating regions grow and compare them to the rate at which new universes form and hot Big Bangs occur. In all cases where inflation gives your predictions that match the observed universe, we grow new universes and newly inflating regions faster than inflation can come to an end. The idea of huge universes far bigger than the meager part that's observable to us constantly being created across this exponentially inflating space is what the multiverse is all about. It's not a new testable scientific prediction, but it's rather a theoretical consequence that's unavoidable, based on the laws of physics as they are understood today. Whether the laws of physics are identical to our own in those other universes is unknown. If you have an inflationary universe that's governed by quantum physics, a multiverse is unavoidable. As always, we are collecting as much new compelling evidence as we can on a continuous basis to better understand the entire cosmos. It may turn out that inflation is wrong, that quantum physics is wrong, or that applying these rules the way we do has some fundamental flaw. But so far, everything adds up. Unless we've got something wrong, the multiverse is inevitable, and the universe we inhabit is just a minuscule part of it. What are the implications? Well, some say the implications could mean there is no individuality. There are infinite versions of you who live exactly the same way you do and make the exact same choices, possibly. The concept of free will is challenged. Did you make that choice because you chose to, or because you're on this dimension of Earth, clockwork universe theory? Every action you take has to include the knowledge that you are creating multiple universes. There is a universe out there where existence is torture and law is set by neo-Nazi and vice versa, where life is ceaseless pleasure and freedom, and it's pure luck which determines where you go. Some would say every established fact and moral standard is up for questioning. In one universe, vaccines cause autism, Hitler did nothing wrong, trickle-down economies do work, and so forth. It could also make existence of our universe trivial, as it's just one of many, many universes, and it is easier to argue with the anthropomorphic principle that our existence is not so miraculous. The multiverse conundrum. Also imagine an Earth where dinosaurs are in our place as the advanced race, or what if we still evolved in that world and live with them? Or maybe not at all. Maybe we are like our chimps and gorillas are to us. Or imagine an Earth where insects are in our place. Imagine one Earth that didn't hit the science age or the industrial age, and religion is in full control. To be honest, I think I saw that saw that world like that in a dream once, and it wasn't pleasant. Imagine an Earth where the Nazis won the Second World War. Where would you be? Would have still been born? An Earth where the Nazis destroyed our soldiers at a bridge too far, and the Soviets took over Europe, and we became part of the USSR. Imagine an Earth where the Marvel universe or the DC universe exists. A universe where magic is real. But there's more to this. There's more layers, because you don't just have the multiple universe idea, but there's also multiple realities. All of these occupy the same space, but on a different frequency, like radio waves do. But we can't access them, as it would require a powerful star drive or gateway which relies on gigantic amounts of energy. If you had something, say, like a gravity drive, that would be possible. Jacques Vallée, a famous ufologist, believed that UFOs were possibly interdimensional, not extraterrestrial. There's also the idea that reality divides or branches off based on your decisions or actions. For example, a reality that stems from the other choice or path you did not take. Also, there's a condition or event that is called the Mandela effect, where people on Earth have had a shared memory of events that seem like they were real and that they happened, but which didn't occur. It is believed that at some point the void between our worlds became blurred and causes this interaction to occur. And also some think that ghosts and shadow men are echoes or beings that rarely become visible due to maybe fluctuations in the frequencies. Also, what lives in the void between these worlds? Lovecraftian horrors, perhaps? Who knows? But whilst there is fascinating possibilities, there will be unimaginable horrors as well. So where do you stand in all this? How do you feel about the multiverse? And do you wonder what life your doppelgangers are living? Or do you not believe in the multiverse, and that we are just insignificant specks in an indifferent universe? However, with the Fibonacci code and sacred geometry, the multiverse is a hard possibility to ignore. Anyway, folks, I'll leave it there. And if you like the video, hit the like. And until next time, folks, take care and be well.